Elon Musk's Neuralink, revolutionizing communication or a risky experiment. The idea of connecting the human brain directly to a computer has long belonged to science fiction. Today, it is edging closer to reality through Neuralink, the neurotechnology venture founded by Elon Musk. Touted as a breakthrough that could transform communication and medicine, Neuralink has also sparked intense debate about ethics, safety, and the future of humanity. At its core, Neuralink aims to develop a brain-computer interface, BCI, a small implant placed in the brain that can read neural signals and translate them into digital commands. Musk has described a future in which people could communicate without speaking, control devices with their thoughts, or regain lost abilities caused by neurological injury. Supporters see this as a revolutionary leap. Critics warn it could be one of the most dangerous experiments humans have ever attempted on themselves. The promise: a new era of communication. Neuralink's most immediate promise lies in healthcare. Early trials focus on helping people with paralysis or severe neurological conditions communicate and interact with the world. By decoding brain signals, a person who cannot speak or move could potentially type messages, browse the internet, or control a wheelchair using only their thoughts. Beyond medical use, Musk has floated far more ambitious ideas: direct brain-to-brain communication, seamless interaction with artificial intelligence, and even preserving human relevance in a future dominated by advanced AI. If successful, Neuralink could redefine what it means to communicate, moving from spoken language to instantaneous, thought-based exchange. For advocates, this represents empowerment. Technology that once relied on hands, voices, or screens could become more inclusive, restoring independence to millions of people worldwide. The risks: safety, ethics, and control. Yet the risks are just as profound as the potential rewards. Implanting devices in the human brain is inherently dangerous. Even with advances in robotics and precision surgery, there are concerns about infection, brain damage, device failure, and long-term health effects that may not emerge for years or decades. Ethical questions loom even larger. Who owns the data produced by a person's brain? How secure is that information? A device capable of reading neural activity raises fears of unprecedented privacy violations. If thoughts can be decoded, could they be monitored, manipulated, or exploited by corporations or governments? There is also the issue of consent and inequality. If such technology becomes widespread, will people feel pressured to adopt it to remain competitive in work or education? Could society split between those who are enhanced and those who are not? Societal impact: humanity at a crossroads. Neuralink sits at a critical intersection of technology and humanity. Unlike smartphones or social media, a brain implant is not something that can simply be switched off or discarded. Decisions made now could shape how future generations think about autonomy, identity, and what it means to be human. Regulators, scientists, and ethicists argue that innovation must be matched with strict oversight, transparency, and global ethical standards. Without these safeguards, the race to push technology forward could outpace society's ability to manage its consequences. Revolution or risk? Elon Musk's Neuralink represents both extraordinary promise and profound danger. It could revolutionize communication, restore lost abilities, and push human potential to new heights. At the same time, it forces society to confront uncomfortable questions about safety, privacy, and power over the human mind. Whether Neuralink becomes a celebrated medical breakthrough or a cautionary tale will depend not just on technological success, but on how carefully humanity chooses to guide it. In the end, the debate over Neuralink is not only about a device, it is about the future relationship between humans and technology itself.